Hey Finxters! In today's lecture, we will be discussing how to declare an array in Python. Now, if Python is not your first programming language, then you must have come across the array data type. So whether it is C or Java or C++ that you have been working in, then you have definitely used arrays. However, in Python, arrays are not built-in data types. Instead of arrays, we have lists in Python. So you can think of a list which is quite similar to an array, but there is a subtle difference between the two. We have to understand the difference between an array and a list before we proceed further. So the difference or the major difference between an array and a list is that an array can consist of homogeneous elements. That is, all the elements in an array are of the same type. So if you have an array, then that means if you are storing integer elements within the array, then all the elements within the array should be integers. Whereas a list can have homogeneous as well as heterogeneous elements within it. So that means a list can either have all elements that have the similar data type, or it can also have elements that are of different data types. So let's have a look at an example. So this right here, which has integer elements 100, 200, 300, 400, and 500, represents an array, and you can also call it a list. Whereas if this is the given data structure, where you can see that one of the elements is an integer, while another element is a floating point number, while the third element is a string, then this represents a list. This is not an array. Now, I hope that you have an understanding about what are arrays and lists. And before we go ahead and declare arrays, there is one more thing that you must understand, and that is dimensions of arrays. Now, you can think of dimension as the number of axes present in an array. So this diagram right here, which you can see on the screen, this one, which has the elements starting from 1 until 10, is a one-dimensional array. Now, I'm not discussing much about the zero-dimensional array because a single element within this array itself represents the zero dimension. So 1 can be referred to as the zero-dimensional array. But when you insert 1 inside the array, such that the array also has other elements within it, like 2, 3, 4, 5 until 10, then this entire thing here represents a one-dimensional array. So when you go ahead and add another element to this array, then it will only grow in one dimension. Or if you go ahead and delete one of the elements, then it will only shrink in one dimension. So let's say if the array is growing vertically, then it will always grow vertically. And if it is shrinking vertically, then it will always shrink vertically. So that is a one-dimensional array. And to make things more clear, you can only use a single index to access the elements of a one-dimensional array. So that is a one-dimensional array. Now that brings us to our next discussion, which is a multi-dimensional array. Now a multi-dimensional array is something like a 2D or a 3D array. So have you heard of matrices? Yes, a matrix is a two-dimensional array. So what is a matrix basically? It is simply an array which has two dimensions or two axes. So as you can see that it has rows as well as columns. Now this diagram here is wrong. I'll rectify this. This is axis 0 or axis X, while this is axis Y or axis 1. Well, the point to be noted here is that it has more than one axis, such that one of the axes represents the columns while another axis represents the rows. So if you want to represent the element in this cell, so each individual element of the array is contained within a cell. Now, how do you access the cell? To access the cell, you have to access it with the help of couple of indexes. The first index will represent the row, while the second index will represent the column. So the first element of this two-dimensional array will be at the index 0, 0, where first 0 represents row 0, while second 0 represents column 0. Similarly, let's say that we want to access the element which is at the first row and the second column. To access that, we need to use the indexes 0 and 1. Now, please remember that indexing in Python always starts at 0. That means the first row will have the index 0 while the first column have the index 0 as well. So indexing, whether it is row or a column, always starts with 0. So this right here represents a two-dimensional array. Well, that was a quick recap to arrays. Now let's go ahead and dive into our mission critical question, which is how to declare arrays in Python. As I mentioned, that Python does not have arrays as built-in data types, but it has libraries which help you to declare arrays. And since Python is the major programming language when it comes to artificial intelligence, machine learning, or data science, wherein we have to play around a lot with arrays, so there's an entire library that has been dedicated towards arrays, and that library is known as Numpy. But we will not only have a look at how we can play around with arrays or how we can declare arrays with the help of the NumPy library, but we will also have a look at numerous other ways of declaring arrays in Python. So without further delay, let us go ahead and learn all these ways of declaring arrays in Python. Now, a slight disclaimer here. This is going to be a two-part video lecture. In this part, the sole purpose is to explain you how you can create a one-dimensional array. In the next part of this lecture, we will go ahead and dive into two-dimensional arrays, and we will see how we can play around with two-dimensional arrays. So for this lecture, the focus is upon how you can create a one-dimensional array. Now, a very simple way to create or initialize an array is to use initializers. So what do I mean by that? Let's say that I want to initialize a certain one-dimensional array which has 5 zeros present within it. So I want to initialize this array which you can see on the screen. So this is the exact array that I want to initialize. So how will I do that? I simply need to go ahead and say that the name of my array is A, and then within a list, I have to pass the value 0 and then use my multiplication operator and then specify the length of this array. So what is the length or what is the size of this array? Since this array has 5 zeros, this means it has a size of 5. So I have to multiply 0 by 5. Now this will go ahead and create this array for me. So let's have a look at that. Let's try and print A. Now let's execute our code, and there we go. As you can see that we have successfully declared an array which has 5 zeros present within it. Now you might also want to initialize this array in a way that instead of zeros, it has some other element. Let's say you want this array to have the element A within it. So this is how you can do this. You have to use the square bracket notation. Within it, you have to pass the element. Then you have to use the multiplication operator and then specify the size of the array. Let's say in this case, we want the size to be 3. That is, we want an array to have 3 A's present within it. Now let's see if this works or not. And there we go. We have successfully declared the array that we want. So this is a very easy and quick way of declaring arrays. Well, there's another way you can do this. Let's say that you want to use lists to initialize this array. That is this array which has 5 zeros present within it. So in order to use lists to declare this array, you have to use a for loop. Hence, let's see how we are going to do this. We will have to create an empty list initially. So let's say that our array A is an empty list initially. Now we have to iterate across the length or the size of this array. So what is the size of this array? The size of this array is 5. So we will simply go ahead and use a for loop such that for I in range 5. And then we simply go ahead and append 0 to each index of this array. That's it. We are simply appending 0 throughout the length of this array. Now let's go ahead and print A. So let's see if this works or not. And there we go. we have successfully created the array that we want. So these were the quick ways of creating arrays, but there are more convenient and more Pythonic ways of creating arrays. Let's have a look at them. Now in Python, we have an entire module named as array, which can compactly represent an array of basic values. Like these basic values can be characters, integers, or floating point numbers. So how do we represent these basic values? For that, they have dedicated type codes. So as you can see, the type code for integer is B, while the type code for initializing the array with characters is C. Now please note that B represents 1 byte, while to initialize bytes, you have to use I. Similarly, we have D for float. Now let's see this in action. That will help you to understand it better. Now array is a built-in module. So let's go ahead and import array first. So import array and let's use the abbreviation ARR for our array module. Now ARR is nothing but a short form which we will be using to represent our array module in Python. So that's how you use abbreviations to represent a module name. For Numpy module, it is going to be NP. For pandas, it is going to be PD. So these are abbreviations that you can use to represent a module. So let's say that we want to create this array. Now, as you can see that this array has floating point numbers. So how do we declare this as an array? For this, we will be using our array module and we are going to say ARR, which represents our array module, dot, and then use the array method from it. And within the array method, we are going to pass this array. And if you remember, we have to also tell Python that these values are floating point numbers. To do that, we simply have to use the type code for it, and the type code to represent floating point numbers is D. So let's go ahead and specify D. So the first argument to this function is the type code, which is D in this case, and the second argument will be the array itself. Now let's go ahead and before we do anything else, let's try to find out the type of A. This should be an object of the array type. Let's check that. And there we go. It shows that A is an object of the array class. Now let's go ahead and try to access the elements from this array. And it's quite simple. You simply have to use a for loop and iterate across all the elements in this array. So for I in A, and then let's simply go ahead and print I. That will print each element of this array. This is the exact output that we wanted. Now you can also access a particular element from this given array with the help of its index. So let's say that I want to access the element or the value 20.8. Since indexing starts from 0, so the index of 20.8 is going to be 2. So this is the first index, that is the value at index 0. This is the value at index 1. This is the value at index 2. So let's go ahead and print the value of array A at the second index. So this should print 20.8. Now you can also use negative indexing just as in case of list. So all you have to do is say print and the name of the array A, and within the square bracket notation, let's say that we want to access the last element of this array. And to do that, you simply have to use negative indexing, which is -1, and that should print 50.8 as an output, or 50.5 is the value. So let's see if this works for us. So we have successfully accessed the elements from this array with the help of their index. So not only did we declare this array with the help of the array module, but we were also able to access the elements with the help of their index. So this is how you can use the array module and declare an array and then access the elements of the array. That brings us to a very important library in Python, which has been dedicatedly created for playing around with arrays. And the name of that library is Numpy. So let's go ahead and find out how we can create 1D arrays with the help of the Numpy module. So what you must understand is that the Numpy module has a method known as array, and this function is used to create an array. So as soon as you use the array function from the NumPy module, it will create an array for you. And within this array function, you have to pass the array that you want to create. And there's one more thing that you must remember. The array object in the NumPy module is known as NdArray. So whenever the array function creates an array, and when you go ahead and try to check the type of that object being created, it will be of the class NdArray. Now the best part about using NumPy module is that you can simply pass a list, a tuple, or any other object that resembles an array to the array function, and it will convert that passed object to an NdArray. So let's have a look at this with the help of an example. Our first task would be to import the NumPy module. So let's go ahead and do that. So I'll say import NumPy as NP, wherein NP is the alias name used for NumPy. As I was explaining previously, that NP is an abbreviation that will represent the NumPy module. Now let's say that we have been given a list li, which has these floating point values. And now we have to create a NumPy array out of this. And it's quite simple. You simply need to go ahead and let's say that A will be the array that we will be using. Then we have to use our NumPy module, which is np dot and then the array method. And within this, we simply have to pass li, which is the list that has all the elements that we want to store within our array A. And that's it. Now let's go ahead and let's use couple of print statements. In the first print statement, let us go ahead and try to check what is the type of our array A. And as I was mentioning previously, it should be of the type NdArray. So this is an NdArray object. Let's also go ahead and print A itself. So we will find out what is stored within A, and we will also find out what is the type of A. Now let's execute this piece of code. And there we go. As you can see that this array is of the type NdArray, while these are the elements that have been stored within our array. Wonderful. Now let's go ahead and find out how we can access these elements. Just like lists, you can go ahead and access every element of a NumPy array with the help of its index. So let's say that we want to access the value 10.5. And as indexing starts from 0, so this value will be at the first index. So let's print a value which is at the first index. Let's execute this. And there we go. So we have 10.5 as the output. And this is the element that we wanted to extract. Now NumPy array also provisions us with negative indexing. So you can also access the elements of this array with the help of negative index. Let's say that we want to access 35.9 with the help of negative index. Now 50.5 represents the negative index -1. So 35.9 will represent the negative index -2. So let's see what happens when we print the element which is at the negative index -2. So let's execute this piece of code once again. And as you can see that yes, 35.9 has indeed been extracted from this array. So this is how you can use indexing and access the elements from your NumPy array. You can also use a for loop. So for I in A, let's print all the values of the array. So let's print I. Now let's execute this piece of code. And there we go. As you can see that all the elements from this array have been printed one by one. Well, this is not the only way using which you can create arrays in the NumPy module. The NumPy module has a plethora of functions using which you can create or play around with arrays. One such method is known as arrange. Now the arrange function will accept 4 parameters. These are a start value such that the start value represents the first element that will be present in our array. Then we have the stop parameter, which represents the last element. Then we have the step parameter, which represents the difference between 2 consecutive elements in the array, while dtype represents the type of elements that will be present in the array. So this essentially means that if we have something like this. np.arrange 1 is the start value, 10 is the stop value, 2 is the step value. In that case, this array will be something like this. It will have the values 1, 3, 5, 7, and 9. So let's check that out with the help of a program. Instead of using this as a comment, let's say that we have an array A, and within it, let's pass the arrange method. So we are essentially creating an array with the help of the arrange method. And now let's go ahead and let's print A to find out what is the output. So there we go. We have 1, 3, 5, 7, and 9. Let's try out some other values. Let's say that we want to start at 10 and we want to stop at 30, such that the step size is 5. Or let's say that we want to start at 10.5 and we want to end at 30.5, such that the step size is 5. Now let's go ahead and execute this. And there we go. We now have our desired array. So this is how you can use the arrange method of the Numpy module to create arrays. Well, that was it for this lecture. Please join me in the next lecture where I will be explaining how you can declare and create 2D arrays. However, if you have any doubts in regards to this lecture, please mention them in the comments below and I will try my best to answer all your queries.